Hello, everyone, and welcome back to another session here at the DIF, where we are tackling today the question of product service systems. Now, businesses that want to stay competitive in the market, and especially in dynamic industries, are combining products and services to better suit customer demands, but also improve sales. At the same time, these so-called product service systems are used to and advocated for narrowing and slowing down resource loops, but also closing them. And what we are talking about today is exactly that. What are product service systems, and especially in a closed resource loop manner? One problem that we have with these product service systems for the moment is the integral character of them, making it very difficult for their design process. My name is Bledar, and today, to shed light on this particular matter, I'm joined by Anouk Ziel van der Laan, who is a PhD candidate at the Dyson School of Design Engineering at Imperial College London. So thanks so much for joining me today, Anouk.
Yes, hi, thanks for having me.
So we are just in a moment going to talk about product lifetimes and these product service systems. But before jumping in this conversation, I want to just say to all of you out there that have tuned in, we thank you first and foremost for tuning in. And if you have any questions along the way, please share them with us. Go to thinkdiff.co at the session page and post your comments in the comment box to the right side of it. Post them on the YouTube stream where you may be just watching this video now, or also on Twitter by using the hashtag ThinkDiff. Now, without further ado, Anouk, I'd like to go first with this term, product service systems. There's 3 words, 1 term. It seems a little bit complex. Is it a product? Is it a system? Is it a service? Is it a combination of all 3? Could you just disseminate this topic for all of our viewers out there?
Sure. Product service systems can be described as combinations of products and services that are designed together to deliver a value to the consumer that is unique because they are combined. So it's an added value because the service is there, and it's an added value because the product is there. And they are together in a system, which means that there might be other elements that are influencing how they are working together, what the dynamics are between the products, the services, and all the other elements in the product service system.
That's fantastic. Thank you so much for that clarification. And now we're jumping into this topic, and we're going to learn much more about them. So please start.
Great, thanks. Right, so Bledar already introduced that I'm a PhD student at Imperial College. I would like to introduce a little bit more about my research. I focus specifically on the fast-moving consumer goods industry. Unfortunately, a lot of the products that are in the fast-moving consumer goods sector, so those are products like packaging and disposable, end up in places like you see behind me. And what you see behind me is an incinerator, and there's an abundance of waste there, which is ending up there because we are lacking systems which allow those resources to flow to a place where they can be actually recovered. And this is the focus of my research. How do we make sure that the resources we use for fast-moving consumer goods end up in closed-loop resource flows? And closed-loop resource flows then mean resources that can be used over and over again. So we're looking at how do we use resources continuously. And product service systems have been suggested in the context of the circular economy to make consumption more sustainable. Often, like you said, Bledar, to make the flow of resources slower, or to make it narrower and to use less resources more efficiently. I look at how can we use product service systems to flow resources continuously. So that means how do we close the loop of those resources? I just want to add to this that a product service system does not always lead to a more sustainable consumption model. To start, I'll just give you an example of a product service system. Uh-oh. Sorry, I'm having a technical difficulty.
We can solve those technical issues in the meantime, but I would just like to see a little bit about these markets. You just mentioned a little bit about how these are not particularly good for any industry and sector. And you just talked about the fast moving consumer goods, so that's one of the sectors. But in the meantime, I would just like to see if there's other sectors that could implement these things. And are we going to see more about that in the presentation moving forward?
Yes, absolutely. Yes, product service systems are used for a variety of products. And my research, my PhD research, focuses on those products that are fast moving. That means all those packaging and disposables. But for the sake of the research, I look at product service systems applied to a variety of product categories. So I don't limit the research to just fast moving consumer goods. Can you see my slides again?
I can indeed. We are looking at Harry's for a moment.
Good, good. So I brought up Harry's because Harry's is an example of a product service system. Harry's offers a subscription to razor blades. So they've introduced a service that makes it more convenient for someone to purchase these blades. And I brought up this example because it's a quite understandable example of a product service system. What I wanted to point out is that this doesn't lead to a more sustainable consumption model. So product service systems can add value, but they don't always lead to a more sustainable consumption. Instead, the reason why product service systems are often linked to circular economy and sustainable consumption is for their ability to dematerialize consumption. That means we can use fewer resources more efficiently. Like Zipcar is a car sharing platform which allows us to use the same car amongst multiple users, so that theoretically would lead to having to produce less cars and using less resources, intensifying the use of these resources. Similarly, Spotify does it by eliminating the need for tangible resources altogether. So they are delivering a result rather than a tangible product. So in my research, I try to answer the question, how can product service systems facilitate closed resource loops? So how do we make sure that we get control over the flow of resources and that we make sure that they don't end up in landfill and incineration, but we can keep using them continuously? And to do that, I look at the use phase of the product life cycle. And I just want to elaborate on product life cycle. We imagine in a circular economy that resources flow in cycles. That means they go from a phase of origin to a phase of production to a phase of usage to a phase of end of life. And in the use phase is where the consumer starts to get involved and the consumer gets access to those resources. The end of life phase is where we would ideally get the resources after use, so that we can start recovering them and pursuing to get them to successive cycles in origin, production, and use phases. So what you see here is the flow of a resource in that use phase. And what I would like to point out is that we would start with resources in an operative state. So when we purchase them, they work fine, they do what we want, we need them, and we're using them. And then gradually or instantly, the resources become obsolete. So that means we don't need the products anymore. We don't really want to use the products anymore. So there's a reason why we are obsoleting them, in which case often they are disposed, but they're not always disposed in the way that we can allow to recover them. So what we want ideally is to get obsolete resources to become recoverable resources, to become in a condition where we can think about how do we get them back into the operative state, or how do we get them back into raw material?
Could I just take a moment to just reflect about that image right there? It's a great illustration and a very simple one to understand how a product is used. And just reflect on the products as conventional. We buy a product and we use it. It seems like the interaction points with businesses is not great. But if in product service systems, I imagine because it's a interaction with the business, that we have more interaction points along the way. Does that hold true?
Yes, we can. So we can think of product service systems, or we can think of services as a means to communicate with our user, or to interact with our user, or with the product. So we can definitely see this as an opportunity. Which we can see a product service system as an opportunity to integrate those moments of interaction and allow to gain control over the resources.
Great,
Does
thanks.
that answer your question?
Absolutely. It feels like it's a whole different dynamic and a much more relationship way of having these products out there in the market.
Yes, I think that's a good way of putting it. It's a very dynamic, it's a system. So there are dynamics of resources, uses of those resources, and where they go. And the idea of looking at product service systems in my research is to see how can we design those product service systems so that they allow us to control where the resources go. So what emerged from my research is a number of functions that we can embed in a product service system, and I'm gonna give you some insights on what those functions are and what kind of principles we were able to extract from the research that would help you to design to satisfy those functions. So the first one that's very important is to intercept obsolete resources. So that means we need to intercept resources to allow to change to one of those previous states of being operative or to go into a state where they are recoverable. So we need to think about how are we going to intercept obsolete resources. And there are two things that are important for intercepting obsolete resources. Firstly, we need to do it because they become a supply in the next phase of the life cycle. So it's important that we gather a volume so that it can satisfy a demand being a supply. And the other thing is the interception of obsoletes is often paired with a lot of recovery and logistics, which are costly. So we want to make sure that we intercept a number of resources so that we can justify the cost for those resources. So I'll give you two examples or two considerations to make in the design of your systems. The first one is a simple matter of providing gateways for obsolete resources. So a gateway is often used in a take-back scheme, and it comes in many forms and types. The way we define a gateway is as a location where a resource can change states instantly. So an obsolete resource instantly becomes an operative resource at this location, or it becomes a recoverable resource. In this case, I'm showing you an example of Gumdrop. Gumdrop places bins for chewing gum all over cities. And as soon as those chewing gums end up in the bins, they go from being obsolete to becoming recoverable. And Gumdrop is able to make a new polymer material from the chewing gum that they collect. So this is the first thing to consider. However, the tricky thing is to actually get those obsoletes to the gateways. So how do you make sure that the materials that are obsolete do not stay around in people's houses or they end up in the wrong bins? How do you make sure that the obsoletes actually get to the gateways? And in many consumer products, the product is in the hands of the consumer. So that means if we want to lure obsoletes to the gateways, we need to attract the consumers to get to those gateways. I'm showing you an example of Repack, who are using reusable packaging that they like to receive back so that they can use it again for another delivery. So users who are opting in for a Repack are incentivized to actually put these things back in put these empty and obsolete envelopes back into the post as they receive a voucher after they've done so. So they are incentivized to do that, and that way we're luring the obsoletes to the gateway.
So now these two examples are very different. The first one has a low value, I can see, and the Repack has a little bit of a higher value. And that's the interplay between incentives as well. If it's a more valuable product, we want to give incentives to people to actually give this back to us. And if it's a little lower value, we just give them the opportunity to leave it in a specific place where then we can do whatever we want. Is that a right reflection, or what would you think about that?
I think there are some good points in your question, because I think the value of resources is very important to consider. So indeed, chewing gum currently has absolutely no value, but by collecting it in those gateways, it immediately ups the value of those resources. Repack has thought about how can we keep the value of our resources. So they've already designed the product differently, making it more sturdy, allowing it to be reused over and over again. So there's definitely a difference in the value, and there will also be a difference in the incentives that people will respond to if they are depending on those different values of products. So for a chewing gum, you might not look all over a city to find that specific bin just so that you can put your chewing gum in. So the incentive must be very, very high, or the bin must be very close to you, or very much in your sight, or on your way to work. So it's definitely a relation between the value and the incentive. Does it answer your question?
Yes, it does.
Great. So the next thing that's essential if you're trying to close loops with a product service system is that you think about, how am I going to transition resources after I've intercepted them? So how do I make sure that those resources are going to go into a successive cycle? And what you need to think about here is that all the resources in a life cycle are continuously exposed to supply and demand systems. So I think I mentioned it earlier that the obsolete resources become a supply in the successive life cycle phase where they need to satisfy a demand. So we need to understand what is the demand that we can satisfy, and what kind of value does my material have when it becomes obsolete. And we've summarized this in 3 guidelines for your design. So the first one is, try to understand what the value of the obsolete is currently. So, sorry, the value partly depends on how much of the material is available. So it's partly volume dependent, and there will be also costs involved for the collection and the recovery process. But there are also external values that you may want to consider. So a second-hand product might be worth more in some countries or in some markets than in other markets. So you can find surprises actually, where you find a market that's very that's valuing recycled plastics very highly, as opposed to a market where they think that's rubbish. So think about, who am I trying to reach, and what is the value of the obsoletes in the location where they are, and all the contextual things that are possibly influencing the value of the resources. So once you understand what the value is, you can think about, how can we optimize the value of the resources so that we can be a supply that's economically interesting. You can think about a lot of design strategies, such as design for disassembly, which allows you to easily take apart products and separate components and different materials. The example I'm showing you here is a materials passport, which is used often in the ship industry, and it specifies what materials are used in the product and where they sit in the product. So this allows someone who is taking back the product to efficiently disassemble and sort all the materials, which makes it a more cost-effective process to go through this. So that's a way of optimizing the value of resources. And often providing information on what the products actually are already a step in the right direction to optimize the value of your resources. Then the next thing that you should not forget is that you actually need to establish that demand for the obsoletes. So you need to find a party that wants whatever you are intercepting as obsolete. And you can always look for a party outside your own product service system, but you shouldn't overlook the opportunity of being your own customer of your obsoletes. And the example I put up here is of a company called SwapFeeds. SwapFeeds leases bicycles. And once you are a customer with SwapFeeds and your bike breaks down, SwapFeeds comes and collects your old bike and replaces it with a new one. And rather than just disposing of all the old bicycles, SwapFeeds uses the bikes and takes the components so that they can repurpose them in other product assemblies. So they are using components that they can take out and that they can always fit to all of their bikes. So it's a way of establishing the demand for whatever becomes obsolete within their own system.
Now, is it in this step where design becomes extra important? Because what I'm hearing is we get all these materials back and all this value back from our products out there. Do we think about design very much early when we design product service systems, or do we think of that after we've gotten back these materials? When does the design principle really play a role?
I think the design principle should play a role early at the design stage, where we are designing products and systems. And I think we should not just design systems. We should not just design products, but we should always consider their entire system. So these guidelines are are to help you to think about the overall system rather than just the product. But you're right to point out that the ones that relate to the transition of resources relate a lot to the actual tangible resources and how they are put together. So that would mean the design of the product, because we can make a lot of decisions there which will influence the ultimate value of the resources at the point they become obsolete. So if you're designing a product that is not disassemblable, that means you're already stuck with something that you can't take apart, so you're likely to be using the materials and the components. I'll continue to the next two functions, which are not as vital as the first two, but they are very helpful in making the other two successful. So we suggest to state the lifetime of your product, as this acknowledges the impermanence of resources, and it increases awareness amongst consumers as well as manufacturers of the fact that there will be an end of life of this product. And it may be a long way from now, or it may be very immediate, but it's important to make this to make the people aware of the fact that products have lifetimes, because if there's uncertainty of how long a product would live, or how long a product will be in use, that could cause to disrupt the response to the obsolete state. So people might not be aware that they have to respond to it, or they might not know how to respond to it. I always like the example of mobile phones and people having a number of mobile phones in a drawer at home just because they feel like they have a reason to keep it, but they don't really use it. So you can think of those as valuable resources stuck in a drawer that we can't be using in another product. And I'm going to give you two guidelines for your design. So the first one is very much linked to the objective of this function. So make lifetime very specific. It's inevitable that there will be obsolescence, and we are already considering the lifetime of product. Think, for instance, of warranty services that are provided with most things that you buy. So it's only a matter of making this specific obvious, for instance. So this is a disposable camera, and when you buy a disposable camera, you know that you get 27 pictures. You can click the thing 27 times, and after that, the camera will be obsolete. All the parts in the thing will be obsolete. So that's that.
Is the number pointed out in this slide? If you can just tilt your computer a little bit just to include that number as well, then we should see how that looks for the people out there.
Okay, you see it now?
That's how it looks, yes.
Yeah, so it's right there. And it's just a simple number. It says 27, and after 27, it's done. And then whether or not you make it specific, or when you have made it specific, you can decide to reveal or communicate obsolescence to allow a better response to obsolescence and to make people aware of obsolescence. So you can think of something that's obsolete that is very obvious. So an empty packaging, for instance, we can see that there's nothing inside. So we can see that the packaging is obsolete. But for instance, a toothbrush with worn out bristles is a much more gradual process of becoming obsolete. And I might be using my toothbrush much longer and accept the worn out bristles as opposed to someone else. So what you can do is use design to communicate obsolescence clearly to your consumer. And I like this example of Uniforms for the Dedicated, who give purchase bag, shopping bags in store that you can flip inside out, and once you flip them inside out, they become a collect and return product. So you can put your old stuff in there, your clothing that's obsolete, and send it back, and they will recycle it or send it to charity. So it's a quite subtle way of introducing obsolescence in whatever you are whatever you're selling as a company. And the final function I want to highlight is governing lifetime. Even though we can make lifetime very explicit, there are always factors that might be influencing the transition to or the occurrence of obsolescence. Think, for instance, that users are all different and they'll all be using your products in different places. So there might be differences that influence how rapidly a product changes to the obsolete state. And governing lifetime simply means that we aim to monitor and influence when obsolescence occurs, which allows us to better predict when resources become obsolete. That allows us to better plan and position how we are capturing obsoletes. So we are planning better moments of interaction and gateways that are exposed to consumers at the right time. And also it allows us to better understand what the quality is of the resources at the moment they become obsolete. So that links back to the one of transitioning obsoletes. If we know better what the value is at a certain time, we can maybe use it to satisfy the customer who is taking our obsolete resources as a supply.
Now, I just have a question that I just missed, but I want to ask you that because it's the right point. In terms of planned obsolescence, we have businesses out there that kind of know what they're doing with their products. Planned obsolescence has been a topic talked about a lot.
Mm-hmm.
And it seems like it's an easy transition for them to make if they go into this domain of the product service systems, because then they can take that knowledge they already have in order to satisfy the new requirements and give people more information out there to know exactly how to work this out. Is that a right assumption to make? And also, if I just can point this out, if you can turn your computer just a little bit to the left, just to have these little words on the right side, then we should be connected and fine.
Better?
That should just a little bit more and we should be fine.
All right.
Like that, thanks.
Yeah, that's a very good point. So planned obsolescence is a term that's often very negatively perceived as it's linked to getting people to buy more. So the idea of planned obsolescence is to make something obsolete with the intention to get someone to buy the same thing or a better thing immediately after. I think a lot of the research around obsolescence has focused on how do we avoid or postpone obsolescence so that we can avoid that unnecessary wastage of products. On the other hand, products will become obsolete. There are not a lot of things in our lives that we are using forever. So it's also wrong to think about obsolescence as only something bad, because it is something inevitable and products will eventually become obsolete, and therefore we need to consider how and when they are obsolete so that we can capture them and make them into a new resource. So I think we can build on the knowledge of the people who have used planned obsolescence in design, and we can bring those design strategies into use in favor of a closed loop and a circular economy. So I'll just go into the three final design principles that relate to governing lifetime. And the first one I want to bring up is aligning changes to the obsolete state with moments of interaction. So the example you see here is Viga, and Viga leases baby clothing, and they send parents a new package of clothing every so many months, and these months the sizes that they send you are aligned with the growth of your baby. So as soon as your smaller size becomes obsolete because your baby is outgrowing them, you will receive a new parcel and you're invited to return all the small clothing back to Viga. So it's a clever way of aligning that change within the resource state to the obsolete state with a service that allows you to intercept the obsolete resources. Even more explicitly is to agree on those moments of interaction. And I think it's a very simple example, but Airbnb you sign a contract with Airbnb when you rent one of the apartments, which says exactly when and where you can enter the apartment, but it also says when and where you need to leave the apartment. So you would be communicating and agreeing on those moments of interaction with, in this case, the owner of the apartment, but Airbnb facilitates this. So it's a way of making it very clear, this is how long I'm going to use it, this is how long you're going to use it, and this is when someone needs it back, so that we can recover from being in the obsolete state to make it some more operative state. And the final one I want to bring up is monitoring resources in use. As I said, obsolescence is the result of a change of the state of the resources. So we go from resources being in the operative state to resources being in the obsolete state. And there are lots of things that may happen to why this is happening. And what I put here is a picture of a phone that says the temperature is too high. So this is a sensor integrated in the phone that measures the temperature of the battery, but maybe there are other elements that you can measure that are influencing the state of this resource. So if I leave my phone in the sun, for instance, for too long, I get the same notification. So we can use these kinds of sensors to inform us on the state of the resources, in favor of understanding the value of the resources, but also in favor of us as the systems providers to plan when there needs to be a gateway, or when we need to interfere, or when we can reverse the obsolete state to being operative. And I think that's where I'm gonna leave it, bringing back the overview of the 4 functions that you can embed in your product service system, which hopefully will lead to closed resource loops in your consumption models.
Well, thank you very much, Anouk, for this presentation about closed loop product service systems and what we should think about in terms of design. What I want to do just before having some of my own questions pop in this Q&A now, I just want to see a little bit of what the people said out there. And we have one comment from our website pointing at the resources and how we can know which resources and products, or just resources in particular, that are in these products. Is there a way for us to know, and where can we find more information as for right now? Now we're looking into a futuristic scenario where closed loop product service systems are the fact, but currently, where can we find more information about it? You mentioned the bill of materials in the ship market. Is there something similar in other markets?
Unfortunately, there's not a lot of that out there. So there's not a lot of transparency yet on what materials and components are in products, and also not in how they are assembled. So there's definitely a need for making that more transparent. I think the opportunity here is if you are a designer and you are designing a product and you're considering the system. I hope that this will help you see that it is important to make your product transparent and make it apparent to people what is actually in the products. Good.
Another question is about ownership, and this is something in conventional markets where I have my phone and it's my property for the moment, and in product service systems, this would transfer the ownership to the companies instead. Is that right, and how does that change the dynamic of products in markets?
That's a very good question, and I think ownership can be a very powerful tool in product service systems, and it can be an opportunity to increase the level of control you have over resources. So in terms of using product service systems to close resource loops, retaining ownership as a provider of that product service system is a huge opportunity to keep control and therefore allow resources to become recoverable resources when they are obsolete. However, it's no guarantee. So we see a lot of product service systems that manage fleets of products like car sharing companies, or I've seen one on construction equipment that are being leased out. And even for those companies, at one point there is a point when those products become obsolete, for instance, when it's too expensive to repair them. And instead of recovering the resources and the materials, the components, they are often selling them to second-hand markets, which means they are escaping the system and they're losing the opportunity to become recoverable resources as they will exit the system. So having ownership is not a guarantee for a closed loop, but it can help.
And how do we break the emotional attachment that we have to this product? You just mentioned earlier in the discussion about these mobile phones that are just sitting there because you had some emotional attachment to it. And quite frankly, I was one of those people at one time. And how do we break that? What do we do in order to make people less attached to the products and just make them interested in the service instead?
That's an interesting question. Well, I see obsolescence as a very interesting phenomena because there are so many causes that can create the obsolete state. And a lot of them are emotional and subject to our judgment. And I think if we understand better what causes us to make something obsolete, it will also allow us to design different ways of obsolescence. So maybe maybe the emotional obsolescence of a link to a mobile phone is not the right one for a mobile phone. If we intend to use all the valuable and very expensive resources in those phones, we would benefit from getting them back. So we need to change that people have that emotional attachment and that they see there is a benefit to pass those phones on.
And we talked also a little earlier about how design is integral to these product service systems becoming more widespread. And especially these should be emphasized on in the beginning of the process. And now for anyone out there that is a designer, among our audience, for example, what are the milestones that a designer would like to accomplish in this process to make design integral to product service systems and make them eventually work?
Yeah, that's also a very good question. We are these guidelines are very much in development. So they are a first version that we are currently developing into a set in which we can include design milestones and toolkits that help the designer to make better decisions. At this point, I would say what you can do as a designer is draw a line or a flow of your materials and see where are all the possible areas that you can lose the materials out of your flow, and how do you avoid that from happening. So I would suggest draw a line of the flow, or draw a flow of the resources to try to understand where they go and how you can design your system to control where they are going.
And if conventional design principles are applied to this product, we have a question from Twitter coming in, just asking about how we make sense of this in terms of, we want to, as a company, for example, implement a closed loop product service system, but conventional design principles and conventional public policy is implemented. How difficult does it make for us to go to that step for the moment?
It's not impossible, I would say. It might be complex if you're using conventional products, but it's definitely not impossible. In my field, where I look at fast-moving consumer goods, for instance, a lot of packaging products are materials that can be recycled and that are widely recycled. So the technology to recycle those materials is already existing. The problem with fast-moving consumer goods is that not everyone has access to recycling systems, not everyone is motivated to engage with recycling systems, and not everyone is willing to actually make that effort, even though they know they should be doing the right thing. So there are different reasons why it doesn't work, and I think we can definitely start with conventional products and try to improve the gaps, or close the gaps in the flow of resources that we currently see. Yes. It might be difficult because you can't control all of the value of the resource at the end. Yeah.
And if we would tie up all of this information that we had in this discussion and your presentation, if we go back to the initial question that we asked very early on, could you just have a brief moment giving everyone of our audience out there a clear explanation, a very concise one, in terms of what considerations have these designers out there to make this a realization?
It was summarizing the whole thing, you mean?
Pretty much, yes. I would just like to go to the beginning of this question. Considerations. Yes. We talked a lot about design. So what should they consider moving forward?
I think what you should consider is the perspective of the material. See how the material is going on a journey from coming out of the ground to going back into a product at the end. So eventually, if we're talking circular, materials will not be coming out of the ground, obviously. So consider how the journey of the material is going to be circular, and then design around that. And then think about all these things that you can consider, how the material changes when it's in a component, when it's assembled in a product, when it's a product that we are going to discard. What do we need the material to be and satisfy when it's in a recoverable state? How do we satisfy recyclers? Think about all the little things that change in the material due to the usage, the production, the recovery, all the elements, I would say.
Now, there's always dissertation season somewhere in the world, and maybe some of them that are very eager to start their dissertation are looking right now and watching us and hearing us discussing all of these design principles, where can they read more about these? Do you have any suggestion on where they should go next?
I'm working on publications of this research specifically. They are not published yet, so I won't be able to share them right now, but do send me an email or connect with me, and I will keep you up to date on when they are available.
And that email will be in the session page at thinkdiff.co, so head there if you want to contact Anouk and know a little bit more about design principles in closed loop product service systems. Thank you so much for joining us, Anouk, today. It's been a pleasure to have you.
Thanks for having me.
And that was everything we had for today about closed loop product service systems. But if you're interested more, as said, you can contact Anouk. You can hear and read more probably there. There's pretty much information a little bit differently probably from what we talked here, but there's much more out there. And there's much more here at the DIF as well. Today we have published our feature-length documentary film exclusively for the DIF called System Reset, so head to thinkdiff.co in order to watch that if you haven't already. And just explore more on thinkdiff.co. We have a lot prepared for you, and we will be seeing you soon again in the afternoon for live sessions where we are going to talk to Unschool, our second session with those students. And we are also going to explore just much more on DIF films. We have DIF podcasts for you. We have prepared everything. So stay at home or stay at school, wherever you are, and just tune in and gather more knowledge. Thank you for tuning in, and see you soon again.